Welcome to this class entitled Economic Analysis General Consideration. This is the first class about economic analysis, and with this class we change perspective because we are passing from the valuation of financial project in the perspective of the investors to a wider valuation of the impact of projects on the economy and society as a whole. So the scope of the analysis will be broader and will concern more subjects than the analysis that we performed using financial indicators on project analysis. So the outline of this class is organized as follows. First of all, we have an introduction to economic analysis. Then we'll have a definition of economic profit. We'll discuss the scope of economic analysis. We'll analyze the price structure, then the breadth and depth of economic analysis. So let's start from the introduction to economic analysis. So for economic analysis, we mean an attempt to measure the impact of an investment project on the national or the regional economy and on the social environment. So decision makers may want to analyze the impact that the potential relevant project is on some important economic indicators such gross domestic product growth and so on. So economic analysis is typically performed by a different set and categories of decision maker, because financial analysis was performed typically by investors that were interested in profits. Now we are talking about economic analysis that is performed by governments and policymakers that are interested instead on the broader impact of a project on a broad set of indicators of economic and social performance at the national, regional level. So you understand that the tools and the objectives and the techniques that will be used in the economic analysis will be different from the indicators and the analysis that instead we have performed in the interest in the investors in the first part of this class. Also because in some cases the perspective of the investor and the perspective of the national government coincide. In other cases, the perspective of the investor can be different and cannot include some relevant aspects that instead are considered by national government. And in this case, we have to correct the analysis and to include into the analysis more aspects or distinct aspects that are able to incorporate into the analysis factors related to general economic growth and society. So in order to better understand economic analysis, we have to start from the definition of economic profit. And in doing that, we have to recognize that commercial profits do not reflect social benefits and costs. So commercial profit typically drive the decision of investors in decision making, but they do not include the social benefits that the project is generating for the society and at the national or regional level. Is not including the cost that the project is generating for the society at the regional and national level. These social benefits and costs will be defined as externalities during this class. This is a very important topic that national and regional governments have to take into consideration when they analyze the impact of a project. And so economic profit has not only to include commercial profit, but is also to include these social benefits and costs that are not relevant for the investor, but are relevant for governments. This means that price adjustments have to be made because they are needed to reflect social value. The prices that we considered in the financial analysis for determination of revenues, costs, investments, and so on are market prices that refer to the price value of resources, but here in our perspective, in our new perspective, in the perspective of the government, these resources also include the social value. So in order to have an appropriate definition and measurement of economic profit, we need to adjust prices in order to include social values. So this is needed because otherwise the focus on the commercial profit could bring to totally unsatisfactory results for the policymaker as compared to investors. So as a consequence, economic analysis is a means of determining social gains by applying adjusted price. So economic profit includes both commercial profit, but also include all the social gains and costs generated by a project. And in order to do that, you have to adjust prices, because if you take market prices, these do not include these other relevant elements that instead are totally important at the level of the national government or region. And therefore, in this way, by determining economic profit, we get a broader vision of the impact that a project is on an economy and society as a whole. So let's try then to understand what is the scope of economic analysis. So we have to consider that the scope of the economic analysis is wider than the scope of financial analysis. This is because within the perspective of economic analysis, a project has more consequences than the consequences that it had in the financial analysis. In the financial analysis, the only consequences of a project were related to the generation of outflows and inflows for the investors. Now we have to consider the fact that the project is not run in isolation, but will generate consequences for the different elements of the society and of the environment where the project is realized. So as concerns the scope of economic analysis, in more detail, we have to consider the project's interaction with regional and national economy. So the project is part of a larger economy, so does not work in isolation, and therefore it is an interaction, tight interaction with other projects and other sectors of the economy, and is producing externalities, as we will see, for these other sectors of project. These externalities could be negative or positive, but however they change the effect that the project is with respect to the effect that we consider only for the financial analysis. So the question that the economic analysis should typically ask is the project investment an appropriate use of economic resources? And this is particularly important when there are two conditions that become relevant aspects of economic analysis. First of all, it's important where resources have scarcity. So this is particularly true for developing countries where there are constraints of different types of both financial and real resources. So it's really important that the resources are used in the best way possible, so that the resources are employed for the project that not only generate the highest commercial profits for the investor, but also generate the highest return for the society and the economy as a whole. And the other condition is that these projects are strictly related to the goods of the society. So if this project is relevant for the society as a whole, it's important that we do not focus only on financial feasibility of the project, but we also focus on the economic and social consequences that the project is for a region or for a country. I would like to clarify, however, that even though the economic analysis has a wider scope than financial analysis, this does not mean that economic analysis is better than financial analysis. Simply, what we are claiming here is that financial analysis is a narrower analysis that is very clear objective, that is to analyze the commercial viability and the value created for the private investor. So the involvement of the private investor, the fact that they produce entrepreneurial initiative is totally important for an economy. So projects cannot survive if they have not commercial feasibility, if they are not creating private value for the investor. So this is some kind of necessary condition for the execution, the selection of a project. What we are intending here instead is that given that the project can be realized because it's a private value, it's for some kinds of project under specific condition, it's also important that we analyze the broader consequences that this project has for the economy. There could be, however, some extreme cases where the project has not a private value for the investor. So there could be projects that will not be funded by private investors because they are not creating value, because they are destroying value for private investors, but are critical for the development of an economy or of a society. So in this case, the project will have such high externalities that should be realized in anyhow, and therefore in this case there will be the need of some kind of public support. So the economic analysis does not exclude the financial analysis. It's a complement of the financial analysis. They provide different results in the perspective of different stakeholders, but they are both important to understand the nature and the contribution and the consequences of an investment project. So say that, let's try to understand better what is the rationale for economic analysis. So why do we need to perform also economic analysis, and we are in addition to financial analysis? Well, the main reason for having an economic analysis, the main rationale, is that is related to the presence of distorted price structures. So what does that mean? It means that the market price do not reflect the true economic value of the resource that is used for the project. So in this case, if I just perform financial analysis that is based on the market price of the resources, I could have distorted result for the economy as a whole. So this is something that we'll analyze in great detail in these classes. The distortion of price structure is really the main reason why we are running an economic analysis in addition to financial analysis, and is one of the main topics of the classes that we have on economic analysis. The other main reason why you are running an economic analysis is because of social imbalances. So you could operate as a government in a context characterized by strong social imbalances in terms of wealth distribution, uneven regional development, unemployment. So under these conditions, it's really important that the project does not only achieve financial objectives, that also achieve results that allow to re-equilibrate and correct, at least in part, the social imbalances. So first of all, we are concerned in perspective of governments about the wealth distribution among social groups. In particular, it could happen that a project contributes to the wealth and well-being of some social group that are disadvantaged. So this is something about which financial investors, private investors typically don't care about. They don't care about who is benefiting from the project, whereas the fact that the project benefits some specific categories of individuals, some social group that have a disadvantage in terms of wealth distribution is really important. So the government will be highly concerned about wages, for example, and by creation of employment in poor regions of the country. Other problem with social with the economy and society as a whole that justify economic analysis, the inadequate domestic savings. So in developing countries, typically you have a constraint to the capital that can be. The second critical assumption is that by definition, fixed costs are the same for every volume of production. So fixed costs by definition do not change with the level of production. So for example, we have rents, general costs, commercial costs. A project, in order to be successfully executed, requires a lot of activities whose amount and whose financial resources do not change with the volume of production. So this cost will be the same independently of the volume of production and sales that they will attain in the project. Then variable costs vary in proportion to the volume of production. Again, this is by definition. Clearly, if the cost is variable, this means that there is some kind of relationship between the volume of sales and the cost measure. So for example, I could know that for each dollar of revenues, I have a variable cost of 60 cents. So this means that the variable cost will be equal to the 60% of revenues. And this relationship will be useful, as we'll see in a moment, to better understand the meaning and the construction of the break-even point graphic. Then the last important assumption is that the per unit sales price that we define as P, small p, and the per unit variable cost that we define as small v are the same for all levels of production. So the relationship between quantity and revenues and between quantity and variable cost are constant independently of the volume of production. Well, this is clearly a simplistic assumption, because it could happen that when the production increases, given the downward sloping shape of demand, the company could be forced to sell the product at a lower price. So here, this assumption, the assumption of constant per unit sales price, implies an inelastic demand curve, at least at the level of the firm, so that the firm can sell any quantity at a fixed price, and the market will absorb any quantity of product at the same level of price. Also, the assumption of a fixed per unit variable cost implies that there are not economies of scale affecting variable costs. So there is not an increase in efficiency of variable cost when the production volumes increase. So there is, for example, no discount on the price of raw materials, or there is no efficiency in the, for example, direct labor costs. So these are quite strong assumptions that, however, could be changed in the analysis, but probably they will not have such relevant effect. So the idea here is to make simple assumptions that give us a very clear result and immediately interpretable result about the minimum quantity that have to be produced in order to reach the break-even point. I would like also to remark that there are some costs that are not fixed or variable, but are semi-variable costs because they have a fixed component and a variable components. So they could be, for example, fixed until a given level of output, and then they could start changing from that level on. And we could introduce without particular problem in the analysis this kind of semi-variable costs, but at the moment they are not strictly needed for the analysis. However, introducing them into the analysis will not be a particular problem from a graphic or analytic point of view. So once that I make this assumption, I can start working on the definition of the break-even point. I can do that both from an empirical and graphic point of view, or from an analytic point of view. So let's start from the graphical representation of the break-even point. Here I have different lines, and then we'll see what is the meaning of each of these lines. So the blue lines that is here is the line of the revenues. So this line is clearly obtained by multiplying the per unit sales price times the quantities that are sold. So as you can see, the revenues increases proportionally with the quantity that I read here on the x-axis. Okay, then we have the yellow line that, as we can see here, represent the variable cost. Also the variable cost proportionally increases with quantity because their function will be equal clearly to the product between the per unit variable cost and the quantity produced. So also in this case we have an increase of this line that is proportional to quantity according to this specified function. Then here we have the fixed costs that are represented by the green line, as you can see here, and is consistently with the assumption that we made before. The fixed costs do not change with quantity, so you can see that the fixed costs are constant for any level of quantity, and the green line is flat, so it's not sensitive to quantity. Then at this point we can sum up the variable cost and the fixed cost. We obtain a new line that is the purple one that is represented by the total cost. So this is the sum of fixed and variable costs and represents the total of the costs that have to be sustained for the execution of the project and for the production that we are considering. So what we can see here is that there are some level of quantities for which the purple line is higher than the blue line of the revenues, and there are some other level of quantities where the purple line is below the blue line of revenues. So in other words, we have an area where the firm or the project is losing money because the costs are higher than revenues. So we have an area of loss that is this one. And then we have another area where the project or the firm are generating profits as revenues are higher than costs, and the profits are represented by the difference between the blue line and the purple line. And so we have here an area of profits. And there is here a point where the two lines intersect. So the intersection of the lines of the revenues, or that is the blue lines, and the line of the total cost, that is the purple line, is exactly the break-even point. So from a graphical point of view, the break-even point is defined as the intersection between the line of the revenues and of the total cost, and represents from an economic point of view the level of quantity that makes revenue equal to total cost. Or in other words, is the minimum level of production that the project has to attain in order not to incur in losses. This means that if we expect that there is high probability that the quantity of products sold by the project in a given year is lower than the break-even point, there is high risk that the project will generate losses. So this is a high risk project. Instead, if we believe that the quantity produced are well beyond the break-even point, we can be relatively safe that the project will generate profits, and so that the project will be convenient, and there is lower risk that the project will generate losses. So not only is it important to define the break-even point, but it's also important to understand how much the quantity that we expect to produce and sell within this project is far from the break-even point, because this is a critical information to understand what the real risk of this project is. Another information that is useful is represented by this traded line in blue that represents the difference between revenues and variable cost. So not revenues and total cost, but only revenues and variable costs. This difference is that you can see also is the difference between the blue line of revenues and the yellow line of variable costs. is also defined as contribution margin. So this line says how much the revenues are contributing for each level of quantity to the coverage of fixed costs. So as we can see here in the graph, at the break-even point, the contribution margin is equal to the fixed cost. So this means that, in other words, you reach the break-even point for this level of quantity because the contribution margin generated by the project for that level of revenues we will be able to fully cover the fixed cost of the project. So in this way, by covering the fixed cost of the project, you are eliminating any possible loss, and at this point you have a zero profit. When you increase the quantity produced and sold, the contribution margin is still increasing, so it's beyond the fixed cost. So this means that you are generating profits and that the revenues are higher than total cost. So the break-even point can also be analyzed from a formal point of view, and we can analyze the break-even point both in terms of revenues and volume. So in terms of revenues, the break-even point will be reached for the values represented by this ratio. So the formula is fixed cost over the per unit price of sales minus the per unit variable cost. Whereas if you are analyzing the break-even point in terms of revenues, you have the product of the price times the fixed cost divided by the per unit price minus the per unit variable cost. So the fifth indicator of risk that we have is the payback period. The payback period is an indicator that we already analyzed in the previous class. In this particular case, we look again at the payback period as a measure of risk. So the payback period is, as you can remember from previous classes, the time needed to recover the initial investment through the following cash flows. And investors generally consider that risk increases with the length of the payback period. So the payback period is a measure of risk because a longer payback period signals a higher risk of the project. So the lower the payback period, the less the risk of the project. And the reason for this interpretation of the payback period is that, as we have already explained in previous classes, long-term projections are more risky than short-term projections, in the sense that it's more difficult to predict the value of future distant cash flow than the value of cash flow that are closer. And therefore, if the ability of a project to recover the initial investment is more based on distant cash flow, this will mean that the project has high risk because you have less probabilities of recovering the initial investment. So the payback period is an indicator that we have analyzed quite in detail in the previous classes. So the main message that we have to remember here is that it can also be considered an indicator of risk because of this property of the long-term projections of the cash flows. And finally, we have the last very important indicator of risk that comes from the application of what we call a sensitivity analysis. So sensitivity analysis is one of the main approaches that is employed in the analysis of a project to determine its exposition to different kinds of risk, and basically consists in modifying some critical assumption to see what happens with the outcomes of the project. So we can define sensitivity analysis as the effect of a change in parameter on project performance. So what does it mean? It means that, as you know, the value of a project depends on the prediction of the cash flows. So each cash flow is being predicted on the basis of several different assumptions on investment, revenues, cost, discount rate. So each of these assumptions could have an impact on the determination of the cash flow, the discount rate, and therefore on the on the net present value. Some of these assumptions could be uncertain. So this makes that also our cash flow projections are uncertain. But some of them could be more uncertain than others, and moreover could have a stronger impact on the value of the project than others. So what we do in sensitivity analysis is the following. If you have a flexible enough model for the determination of cash flows and present value of a project, we try to change, will require to change the interest of some specific parties. So typically it's hard to face and contrast the economic inertia. So these measures are not taken. Another issue is related to political conflicts, clearly removing barriers or that reduce market perfection, or to include externalities into price structures is important political consequences, and in particular will harm some specific groups within a society. So there will be typically resistances from these groups that are harmed by the decision that you can make when you include externalities into price, or you decide to remove, for example, the constraints on trade. And there is a general resistance to include externalities in pricing system, because this typically implies higher cost for a product or for a firm. Typically when you have a regulation for pollution that charge some cost, for example, for the disposal of the products that a company sells, this changes the cost structure of the production of that particular good, and this is clearly an important consequence for the profitability of the company, and therefore typically there is opposition by lobbies or specific groups of firms that sometimes impede the adjustment of prices to include externalities into the price. So we have the last topic of this class that is related to the breadth and depth of economic analysis. So economic analysis is by definition costly. So as we'll understand in the next classes, economic analysis is a complex task, requires a lot of information, require a specific team of people working on the evaluation of projects, and so it's not a straightforward activity. It requires the allocation of a budget. So the question is, how broad and how deep should the economic analysis be? And this is an answer that we can provide on the basis of some considerations that have to do with the nature of the project that is to be analyzed. So breadth of economic analysis should be limited to those items that have both large impacts and large distortion. So what does it mean? It means that not all the projects that have a large impact on the economy also create a large distortion. There could be projects where the financial and economic impact are quite aligned, where the project is important both from the financial point of view and from the economic point of view, and the objectives are consistent, are coherent. So there is no distortion in the price structure. The value of the resources and that are used in the project are in line with the economic value. So in this case, we don't need to carry an economic analysis. It will be useless because there is no distortion. On the contrary, you could have projects that generate large distortions, so where there are important differences between the financial and economic consideration and between the market price and the economic value, but that have not an expected impact on the economy. So also in this case, the sole presence of distortion would have no implications for the need of having an economic analysis. The second dimension that we should analyze in economic analysis is the depth of economic analysis. And we in particular, we intend the depth of economic analysis is with respect to the dimensions of time and space. So in other words, here the question is how long and how deep should we carry our economic analysis? And here the problem is that when we look at a project, the project has externalities that could be related to the closer region, or could extend to several other regions, or to several other sectors of the economy. So you could have externalities that are clearly identifiable and refer to a specific geographical space or industrial context, or externalities that are more indirect, but that in the end also affect other regions and sectors of the economy. Moreover, these externalities could be observed in the short term, or could be observed in the long term. For example, infrastructure project could generate immediate externalities, but could have an impact on the long-term growth of that region that we can observe only in 20, 30 years. So here the problem is, should we concentrate only on the externality of that are closer to the project, or to all the externalities that the project is generating at the national level? And should we concentrate only on the externalities that are realized in the short term, or we should look at all the externalities, including the ones that will be realized only in the long term? Well, again, the answer here depends on the criteria that we saw before. So if a project is a large impact and is large distortion, clearly it's better to have the deeper economic analysis that we can afford. So we should investigate externalities both for a long time and for a wider space. On the contrary, if a project has a lower impact and distortion is lower, we can also focus on local externalities and short-term externalities, avoiding to extend the analysis to those externalities that are also more difficult to measure, that refer to distant spaces and to the long term. So all these aspects will be analyzed in detail in the classes that will follow. So this class is ended. I thank you for the attention, and I remind you that as usual you can find additional materials about the topics of this class on the course website. Thank you.